Another thing that we can look at is here in example 513, and you want to estimate the probability that a patient will develop an infection while hospitalized at a particular hospital. We have data from the last year and see that the hospital had 6,450 patients total, and 712 of them developed an infection. So what's the estimated probability that a patient will develop an infection? So based on what we've seen in the past, the probability here would be 712 over 6,450. Now, with fractions that are this large, people tend not to have a good skill at estimating what this fraction is. So instead of trying to reduce it or anything like that, just get a decimal. And in this case, and I usually do 4 decimal places for probability. And so the probability here is 0.1104. So that's about an 11% chance of these patients developing an infection. In the next example, we're looking at that same Chronicle for Higher Education Almanac in 2016, and we see there were 1,003,329 associate's degrees in the year 2013-2014. A total of 613,034 of these were awarded to women. So if you randomly were to pick one of those million students, what's the probability that the selected person will be female? So here we can see how many females there are. So that's going to be the number of outcomes in the event that we're considering, divided by the total number of people in, or the total number of observations that we have. Now, again, this is one that people would probably not be able to do well with estimating. You might be a little bit better because the denominator is close to a power of 10, but still I would recommend going ahead and getting a decimal here. So this is approximately 0.61, and that will actually round to 6110. Just as a note, if you are being precise, we did technically round, and so it's only approximately these decimal values because of the rounding. So if you want to indicate that you have rounded, then that's a good skill, that's a good symbol to use. Now let's look at the next one. What's the probability that the selected person will be male? Now, for the purpose of this problem, we're going to assume that the only choices here were male and female, but that's not necessarily a given. So, we want to consider that before we look at how we would calculate this. But if everybody was given either male or female for this data set, then male would be the opposite of female, and we could use the complement. And so we could actually do 1 minus, and it's okay to go ahead and use the decimal form because you're just going to round if you use the fraction form. So just use the decimal form, 1 minus 0.6110, and so here the probability of male is 0.389. And then the last example in section 5.2 is looking at these 6 people who hope to be selected as a contestant on a TV game show. 2 of these people are younger than 25, and 2 of these 6 will be chosen at random to be on the show. So let's think about the sample space. So we've got 6 people. I'm going to label them A, B, C, D, E, and F. So the sample space here, I need to make the list just like I did in the earlier problem. So I'll start with A, and I'll go down the list. Just have a longer list this time. And go to B, pair B up. Then go to C, and pair C up. Then go to D, pair D up. And then our very last one, E with F. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 different ways that this can be done. So are the outcomes in this sample space equally likely? Yes, because they're randomly chosen, we can see that these would be equally likely. Now, 2 of these people are younger than 25, so let's just pick 2. Doesn't matter which 2, we're just going to pick. So I'm going to go with A and B. And with that in mind, what's the probability that both will be younger than 25? Well, the only pairing up here that has just A and B in it is this very first one. So there's only one out of these 15 options. Now, 1 out of 15 is starting to get into the types of fractions that you might want to go ahead and get a decimal. And so this one is approximately 0.067. And then now for D, what's the probability that both chosen are not younger than 25? Now, a lot of people would think that that's the opposite of C, but that's not actually the case. The opposite of C would be, what's the probability that neither of the contestants are younger than 25? And that's very subtle, because the opposite of both is actually just that either one of them is not. So this question D is actually a little bit different, and we're looking for where both would not be younger than 25. And my list, that's all of the ones that don't include A or B. So that's these, so we've got 4, 5, 6, and then everything else either has A or B, so that would not work. So you can see that we did get a very different answer than the opposite. So you've got to be careful when you're using the opposite that it really is the opposite. And then the last question, what's the probability that one is younger than 25 and the other is not? So this specifically is that you have one that is A or B and then the other one is not. And what's going to happen is this is actually going to pick up the rest of the cases here. So that's going to give us the other 8 out of 15. And that is approximately 0.533. And I ended up using 3 decimal places here, 3 or 4. WebAssign will tell you how many to use. And so that is it on section 5.3. And there's one more section in chapter 5 that we will be looking at, and that's looking at more complicated probability questions.